Okay, so I'm not going to sugarcoat it for you. This one's a bit of a bear. It's not necessarily difficult, but there are a lot of facets to this problem that we need to keep straight. Now, the good news is that this really kind of serves as a nice, I think it's often referred to as like a capstone problem, where we get to go back and review many of the techniques that we've talked about in the previous examples, and we're just bringing them all together in this one problem. It's going to get a little bit messy, so organization is going to be crucial in this one. Now, we've kind of gotten in the habit already of referencing the powers when we have products of sine and cosine. And in this case, we'd be looking for an odd power. There isn't any. So in the case where there are only even powers, so when there are only even powers, and this would even go if it was just sine squared dx. If there's just an even power, what we're going to end up using are the power reducing identities. So we use the power reducing identities, and those are on the first page of the notes as a reference if you've forgotten them. All right, so since in this particular problem we could say that we've got the integral of, we're going to need to write this as sine squared squared in order to use that power reducing identity. And now, using the power reducing identities, what we have is we've got the integral of, for the sine function, it's 1 minus cosine of 2x over 2, quantity squared. And then for that cosine squared, it's 1 plus cosine of 2x over 2, and this is not squared because it's just cosine squared. We didn't have the squared, and then that's dx. All right, so this is quite a mess. We just need to kind of do a little bit of cleanup here. Now we can, since we've got that 2 in the denominator being squared, let's go ahead and pull that out as a 1 over 4. So that's coming from that 2 squared. And then I'm going to also pull out that 2 in the denominator of the cosine there as times 1/2. So if we pull those both out, we are left with 1 minus cosine 2x quantity squared times 1 plus cosine of 2x dx. And I wish I had better news, but at this point we just need to multiply everything out so that we can do term by term integration for this one. So a little bit tedious, but we'll get there. So we've got 1 over 8 times the integral. If we square out this 1 minus cosine, we're going to get 1 minus 2 cosine of 2x plus cosine squared 2x. And then that still needs to be multiplied by 1 plus cosine 2x dx. And if we then multiply all these terms out, so if we distribute each of these together, so we'll have, let's see, so we'll have, we distribute the 1 first, we're going to have 1 times 1, which is 1, 1 times cosine 2x, which is plus cosine 2x. If we distribute the negative 2 cosine 2x, we're going to have negative 2 cosine 2x minus, and then if we multiply it by cosine 2x, we're going to have minus 2 cosine squared 2x. And then if we distribute the cosine squared, we're going to get plus cosine squared 2x times 1, and then plus cosine cubed 2x, and then we're finally done with that, so that's dx. Still very gross looking, so let's go ahead and see if we can combine some like terms. I'm looking at this and I think we can combine this cosine 2x term and this cosine 2x term, and we can also combine these cosine squareds together. And if we were to do that, we now have 1/8 times the integral of 1 minus cosine 2x, and then minus cosine squared 2x plus cosine cubed 2x dx. Okay, good news, we're done with combinations and simplifications. Now we've got to integrate this, and we're going to have to go through and integrate each of these functions one by one. I'm going to go ahead and actually treat them individually just to keep it organized, because it's a lot to keep track of. So off to the side here, we're going to do I'm going to integrate these each individually. So let's start with let's start off easy. So let's do the integral of 1 dx. So that's just going to give us x plus c. All right, so we're going to put that off to the side and talk about that again later. All right, next we've got the negative integral of cosine 2x dx. So this is not too bad. It's a very simple use substitution formula, or just a formula if you have it memorized for the integral of cosine of k times x. That's just going to end up being negative from the negative outside the integral, 1 over 2 sine of 2x plus c. All right, so we've got that one to add on later as well. All right. I hope you enjoyed those easy ones, because now it's not going to be quite as fun. So the next one is negative cosine squared 2x. Now let's think about this. We are integrating a sine or a cosine, in this case a cosine, with an even power. We just talked about this at the start of the problem. So since this is an even power, we kind of talked about the idea of using the power reducing identity. So that's what we're going to do here, is we're going to use the power reducing identity and rewrite this as the negative integral of 1 plus the cosine of twice that angle, which would be 4x, all over 2 dx. Now in integrating this, I'm going to pull that 1/2 out. So we've got negative 1/2 times the integral of 1 plus the cosine of 4x dx. And if we were to integrate this, we'd have negative 1/2. The integral of 1 is just going to be x. And similar to the last one that we did, we've got the integral of cosine of a constant times x, which is going to be plus 1 over that constant times the sine of 4x. And then that's just going to be plus c. So I'm going to summarize this as being negative 1/2 x minus 1/8 sine of 4x plus c. So again, we'll make note of this, put it off to the side, and go from there. All right, so we've got one left, that cosine cubed of 2x. So next one is the positive integral of cosine cubed 2x dx. And we actually started off these notes integrating a cosine cubed. Now that was just cosine cubed of x. This is cosine cubed of 2x. The procedure is the same. We just need to mind our use substitutions in those, the coefficient there. So this is an odd power. So using the tip we had before, we're going to borrow 1 from the odd power and then set up our integral. So this is going to end up being the integral of cosine squared 2x times cosine of 2x dx. So I borrowed 1 of those cosine powers. And then we're going to write this as the integral we're going to rewrite that cosine squared using the Pythagorean identity as 1 minus sine squared 2x times cosine of 2x dx. And what we will do at this point is our u substitution. So we'll kind of get this going off to the side. If we let u equal the sine of 2x, our du is going to be, now this is a chain rule, so the derivative of sine of 2x is 2 times the cosine of 2x dx, which yields 1/2 du is equal to the cosine of 2x dx. And if we do our u substitution off to the side here, so that's going to be what we pull that 1/2 out, and we're going to have the integral of 1 minus u squared du, which would give us 1/2 u minus 1/3 u cubed. And if we bring that back over here, sorry, so if we then substitute back in for our u, what we're going to have is 1/2 u, which was the sine of 2x, minus 1/6 sine cubed 2x plus c. And that's our last integral. All right, so let's take a breather here to kind of reassess what we've done. We've gone through from that original integral up here, and we have individually integrated each of those 4 components of the integrand. And now it's time for us to just put them all together and wrap this up. So we now have remember we started off with, it was the integral of sine to the power of 4x cosine squared x dx, way back when we started this problem. And this is going to be, so we've got that 1/8 from the start up there, times, now we're just going to lump all these terms in together. So we're going to have x, we'll save the c's for later. We're going to have minus 1/2 sine of 2x plus c, and then we've got that, what, minus 1/2 x minus 1/8 sine of 4x, and then the plus c. And then we've got, from the last one that we just did, the plus 1/2 sine of 2x minus 1/6 sine cubed of 2x. And then I'm just on the very outside, I'm just going to put, if we combine all those arbitrary constants, we just get a new arbitrary constant. If we were to combine like terms at this point, so if we combined the x and the minus 1/2 x, that's just going to give us 1/2 x. If we combined the negative, if we combined the negative 1/2 sine of 2x and this positive 1/2 sine of 2x, those are actually just going to cancel out. So we're just left with the remaining terms, minus 1/8 sine of 4x minus 1/6 sine cubed of 2x plus c, and then finally we distribute that 1/8, and we're going to get the following: 4x and then minus 1/48 sine cubed 2x plus c. So I warned you, this was a bear, and it was just a lot of different facets to this particular problem. You know, we started off with even powers using the power reducing identities. Then we got tossed an even and an odd in the process, along with U substitution. It was a lot. So if you can kind of see your way through understanding our steps in this one, I think you're in pretty good shape. And then the last thing that I would mention here is that we've talked about some tips, and I just summarized each of them here below in terms of odd powers and even powers, so you can reference as you're working through the rest of the problems in this section.